just for our understanding, actually both are suspended at same point because they're having different time period. This will be X, this will be Y. They'll start oscillating. But look at the time period of oscillation. When X takes 4 seconds, what about Y? Y when X completes one vibration means one cycle. What about Y? Y would have not completed. Somewhere maybe just about to complete. Both are given same angular displacement. I think we are not talking. Both are initially released from same position. So will be. But how much of time? This will take 4 seconds to complete one oscillation. By the time X completes one oscillation, what about Y? Y would have not completed. I think this is the basic condition. How to deal with such problems? Again, they'll be in same phase means what should be the initially they're having zero phase, no? Initially they're having zero phase. Then again they'll be in same phase means what should be that one? That should be equal to 2 pi radian. So we will go for like this, theta 1. The phase angle cannot be zero. Again they'll be in same phase means it should become equal to 2 pi. So what is theta 1? Theta 1 should be equal to. So the time will be 2 pi. So this T1 will be 4. How much it will be? 116.8 by 0.2. 81 seconds. This is the and but how many vibrations is asking. After 81 seconds, both will be in same phase. But how many vibrations of X? The X for one vibration, the X will take 4 seconds. For 81 seconds, how many vibrations? For 4 seconds, for X, 4 seconds it will take for one vibration. For 81 seconds, how many vibrations? So N should be equal to time taken, no? Oh, 84, huh? Just check 168 by 2, 84. So this will become 84 by 4. How much it will be? 21, huh? Yeah. After 21 vibrations, again, after 21 vibrations of X, again, they'll be in same phase. Why we should think in this way? See, initially, what was the phase? Zero. After some time, the phase angle should become 2 pi, no? So why you can't write 4 pi? Yes, we can write 4 pi, we can write 6 pi. But what was the question? After how many vibrations of X, they'll be in same phase. After how many vibrations? If you write 4 pi, yes, 6 pi, it will be. after is used. If more than one option comes, then you have to go for again 4 pi, 6 pi also. Since single option, okay, we are going for the least value. Any doubt you can clarify? Anybody having doubt, you can clarify. Okay, we'll take some compound pendulum one. There's about a physical pendulum or rigid body oscillations.